Whenever I feel to connect beauty and nature with physics, I think of rainbows. They immediately come to my mind. Why? Just think they're so beautiful to watch. Such a natural phenomenon, pure beauty. But besides the outer appearance, by outer appearance I mean the first glance, if you observe closely, you will see something repeating. What's repeating? Obviously, the order of the colors, the shape of the rainbow, everything repeats every time it appears. Why? Have you thought of it? Now let me ask you something else. Whenever a rainbow appears, we know the 7 colors, right? With Geor. They are arranged. They never change their order like we do when the teacher is out. No. The colors never change their order. They are so disciplined. And every time the shape of the rainbow is also specific. The shape also doesn't change. Why? There must be some reason, right? And it is our tendency, if something repeats again and again, we go behind to find the reason. And yes, that is why I have named this series Exploring Dimensions, where we, yes, you and me, we are going to explore the secrets which nature has kept for us in the form of physics. Yes, that is physics. I don't want you to think of physics as a subject. No, physics is a language, just like you study your poetry, right? In that each and every line, if someone asks you to explain any one line of a poetry, you will give a full paragraph explanation for that single line. How beautiful it is. So much feelings compressed in just little amount of words. Yeah, that's physics. So I want you to think physics, to consider physics as a language. Coming to our case. Till 9th standard, whatever you did, you played PUBG. You went out, you played cricket, now you can't go out. You are at home. Okay, we'll observe the indoor phenomenon to understand physics, right? So till 9th standard, whatever you did, doesn't matter. You were not good at studies, doesn't matter. I was not good at study. Yeah, I didn't take studies seriously till 10th standard. Only when I came to 10th standard, I felt the heat. Yeah, so doesn't matter. Forget your textbook, forget your previous marks, just feel the physics, and I assure you that everything else will follow you. So coming to our subject, our first chapter or our first exploring topic is force. So what is force? See, when I studied, my favorite definition of force is a push or a pull. It's so simple to remember, I just loved that definition. Whenever someone asks me what is force is a push or a pull. But does that convey anything to you? Is that true? Yes, it is true. Force is a push or a pull. But is that all? No. You must dive deep into understanding what is force. So just listen to me and tell me if I am wrong. Okay, reply me. I am going to categorize this force. I am going to apply force on a rigid body and on a non-rigid body. Now, what do I mean by rigid body? Any body which is not easily compressible. Compressible. What do I mean by compressible? Means which is not easily stretched or crushed. Anything like a pen, like a book, like a cricket bat, cricket ball, football, basketball, anything with which your mother beats you, everything is rigid. Belt, okay, you can imagine like that. Okay, so rigid body, that's a rigid body. If I apply a force on a rigid body, what will happen? Yeah, the body will move. There will be motion. So if I apply a force on a rigid body, the body will start moving. Now take the second case. When I apply force on a non-rigid body. Now non-rigid body like a sponge, like an elastic rubber band. If I apply force on such things which are not so rigid, what will happen? See, movement will happen, it's for sure. If I throw a sponge, it will go and fall. Movement is for sure, but will something else happen? Think of it. Just think that you are applying force, you are crushing a sponge. Yeah, I said it, the shape will change. The shape of the body will change. Similarly, if you apply force on an elastic rubber band, the form will change, it will get stretched, the shape will change. Right? That's it. We are done with the first part, that when force is applied on a rigid body, the body moves. Means force can create motion. But when it is applied on a non-rigid body, it will create motion, but at the same time, it can change the shape of the body also. Right? We have seen it, right? We see these things in our daily life. The only thing which you need to learn is to write it down in your examination, in a paper, on a paper. Please forgive me on my language, okay? My English. You understand, no? That's enough. Okay. Where were we? Yeah, the only thing that you need to learn is to write it down on a paper. 80% of the things that you are going to learn in 10th standard is based on what you see in your daily life. What you need to learn is to write it down on a paper. And we'll learn it here, don't worry. So taking the next topic, force. Let me ask you this before going to that. What is the difference between weight and mass? Think. Is there any difference between weight and mass? Is weight equal to mass? Mass is the amount of matter contained in a body. Taking my case, my mass will be the matter contained in me. But my weight will be the force with which gravity is pulling me. So gravity is pulling me. Yes, gravity is pulling all of us. If you are sitting, it's because gravity is pulling you, or else you will be floating. Right? So the force with which gravity pulls us towards itself, the earth pulls us, is our weight. So can I say that my weight is variable? Yes, I can say that, right? You know that. In 9th standard we had this give reason question also. In moon, why is the weight lesser and mass is fixed? Yes, the mass of a body is always fixed. Whether I am on earth, whether I am on moon, doesn't matter. My mass is fixed. But my weight may vary. My weight on earth is heavier than my weight on moon. I know that you are smart, you know these things. Moving forward. Do you remember Newton's second law of motion? Where Sir Isaac Newton gave this expression, force is equal to mass into acceleration. Okay, some of you may remember it. I didn't know about it, okay, till my 10th standard. I told you, I took study seriously in 10th standard also. So if there is some person getting demotivated that he didn't study for the previous years, nothing matters. It will affect you in your 11th standard. Your 9th standard topics are related to your 11th and your 10th standard are related to your 12th. Okay. So no worries if you are not that good with your 9th standard topics. We'll start from fresh. Okay. Where were we? Force is equal to mass into acceleration. Now I'm not going to Newton's second law of motion. I'll give you the definition. I'll give you the reason why force is equal to mass is into acceleration. In your textbook it is said that linear momentum, it's a quantity, it's a physical quantity, which is equal to mass into velocity. So in your textbook it is given that the rate of change of linear momentum is known as something like that. Let me simplify that. You don't need to mug up those things. We'll simplify that. What do you mean by rate of change? Do you know that velocity by time is equal to acceleration? Obviously. That you should know, okay? Don't act stupid. That's a basic thing that you should know. So velocity by time is equal to acceleration. We are talking about rate of change of linear momentum, which is rate of change of mass into velocity. If I write mass into velocity by time, that's rate of change, right? So mass is a constant. It won't change. What will change? Velocity will change. So mass is a constant into change in velocity by change in time. That's acceleration, and that's why force is equal to mass into acceleration. If you didn't follow, doesn't matter. Just take your textbook, the first paragraph is this. The derivation is there, just go through it. Okay. Now, we know that all physical quantities are classified into two kinds. Number one, scalar. Number two, vector. You know the difference. See, if I have a mass of 2 kgs in this hand, right? And I have a mass of 4 kgs in this hand. Now, however I place my hand like this, I do this thing, anything, but the mass won't change. I don't need to represent direction that I am holding 2 kgs in that direction. No. Mass is just a number. So can I say mass is a scalar quantity? So scalar quantities are those quantities which require only the magnitude. But when we take the case of vector quantities, we must represent them with the help of a direction. They doesn't get satisfied with magnitude. They want direction also. Now think here. Is that those quantities need direction? Or is that for us to understand them, we found a way to represent them with the help of a direction? Right. So it's not that those quantities which need a direction are known as vector quantities. No. Those quantities which for us is difficult to understand in terms of just numbers, we thought of giving direction to make things easier. That's it. Take it easy. That's a vector quantity. We represent them with the help of a magnitude as well as direction. Now I'm going to ask you this question, and I know that you know the answer already, but still. Force comes under what? Scalar or vector? Simple example. You are standing with your friend on a bank of a river. Okay. And unfortunately you are the naughty one and your leg slipped. Okay, now you are going to fall. It depends on your friend whether to save you or not. If he apply a force against you, you will definitely fall and you may even. But if he apply a force towards him, then he save you, and that's the importance of direction when we talk of force. I hope that's clear. Right. Now, okay. Let me ask you, what's the SI unit of force? Now, why we represent everything in SI unit? Why I have to mug up these SI units? Can't I just say in the units which I like? There are numerous units, right? There are many units for a single physical quantity. I'll represent it in the way I like. But just imagine, you represent a physical quantity in the unit in which you like, and you have to convey this thing to a person in another country. Right? Now there comes the difficulty. Not only in another country, maybe some other place also. Some other institute. It's just like languages. If you see, I just imagine, I don't know Telugu and you are coming and speaking to me in Telugu. Will I understand something? No, right? So for us to understand, to be on the same page, we must communicate in the same language, and that can be correlated with SI units because it's a standard. Anybody across the world will follow that, should follow that. That's why we fixed it. SI units are fixed for that reason, so that there are no confusions, there are no communication errors, there's simplicity, easiness, for our convenience. Human beings did everything for their convenience, right? And we actually consider physics as a tough subject. Every subject is a tough subject till you take it as a burden. But once you start to love the subject, or if you start to understand the subject, then everything is easy. My teacher, my class teacher in 10th standard, she used to say that don't study hard, study passionately. Yeah. Okay, moving forward. Where were we? See, I forget in between. Yeah, SI unit. The SI unit of force, yeah, you said it, it's Newton. But let me ask you, what do you know about Newton? See, SI unit of force, what's force? Force is equal to mass into acceleration. So SI unit of mass is kg. SI unit of acceleration is meter per second square. So SI unit of force is kg into meter per second square, and that term is named as Newton. Right. Okay, that's Newton. So you must know, if someone asks you what's the SI unit of force, Newton is enough, but you must know what is Newton. Similarly, we have a CGS unit too. So we have gram. You tell me, what's the CGS unit? Yeah, mass gram. Acceleration, CGS unit is centimeter per second square. So the CGS unit of force becomes what? Gram centimeter per second square. And that too should have a name, right? The name is dyne. Is there any relation? Yes, 1 Newton is equal to 10 raised to 5 dyne. Okay. So we are done with the major topic, to understand things. We are done with the basic understandings. Now I know there are many people who think that basic understanding, no, I'll just skip it. You're being stupid. I'll tell you why. See, deeper the roots, higher will be the tree. Deeper the foundation, higher will be the building. Deeper your grip on basic fundamentals, higher will be your knowledge on that topic. Understand this fact and act accordingly. Okay, moving forward. So, we learned about going to the first point, that force when applied on a rigid body moves the body, and force when applied on a non-rigid body, movement also happens and the shape also changes. We'll leave that case there. We'll take the first case on a rigid body case. Now we are going to learn about movement. So in our 10th standard, we need to learn of only 2 kinds of motion. Okay. Now does that imply that there are only 2 kinds of motion? See, we are students, right? We are children. Not only children, everybody. See, I will run, I will walk, I'll go upside down, I'll do random things for no reason. I execute so many kinds of motion, right? So, for the sake of simplicity, in your 10th standard syllabus, they have included only 2 kinds of motion. Thank God, right? But you must also try to find out about others. Anyway, you learn them. But still. Okay. So, we'll take examples. Let me bring another person here. Not actually person, something. Yeah. This is a ball. Now, I'm going to, first of all, notice something, okay. This ball is free to move. That means it is not fixed. It is not fixed to any point. This ball is free to move and it is a stationary ball. Now what do I mean by stationary? The place from where we buy books and pens, right? No, Just kidding. So stationary means which is not moving. This body is stationary and it is free to move. Now, if I apply force, okay, just observe, I am applying force on that direction and the ball started moving. Right? So what did we say? A body which was stationary and which was free to move when a force was applied on it, it started moving. See this once more. It started moving. See, I am applying force that way. Is that going towards you? No, right. It will go in the direction in which I apply the force. When you play football, when you kick a ball, does that ball go and come back hit you? No. It will go in the direction where you apply the force. Right? So point number 1, body is stationary. 2, it is free to move. 3rd, when force is applied on it, it moves in the direction of force. Now tell me this thing. Let me ask you seriously. Was there even one point which you haven't experienced earlier? These are the things which you do in your daily life. Now this is named as linear motion or translational motion or rectilinear motion. That's all. We are done with the motion kind 1. Translational, yeah, or rectilinear kind of motion. We are done with that. Yeah, that's it. I'm seriously. That's all. Now go and mug up. Why do you have to mug up the definition now? I told all the points, right? 3 points. That's enough. You are done with that. Now you'll ask the second kind of motion. The second kind of motion. One more person. Now it's very hard to fix a ball, right? To a point. I have this thing. I have made this for you. See. Okay, so I'm going to fix this. Just imagine that I fixed. Yeah. Okay. Now this body is not free to move. What's the technical term for fixed in physics? It's known as pivoted. Yeah, that's it. That's pivoted. Nothing rocket science things. No. When a body is fixed, we say that body is pivoted at a point. Now this body is pivoted at this point. That implies it's not free to move. It can't move in random ways. Right? It is fixed. Now this is its axis of rotation. And what do I mean by axis of rotation? The point about which the body rotates. Right? The point about which the body rotates is the axis of rotation. The body, it's named axis of rotation, right? That point. Okay. Now observe. Now when I applied force on the ball went straight. But you know by saying this that if I apply force on this thing, what's happening? I'm applying force on the same direction only, straight, but it's not going there. It's rotating. That's the second kind of motion, and that's it. Yes, that's it. And this kind of motion is known as rotational motion. Then, yeah, we are done with 2 kinds of motion. So, kind number 1 was translational or rectilinear motion when the body is free to move, it is stationary, applied, a force is applied, it moves in the direction of the force. Motion number 2. When a body is pivoted at a point, pivoted means just fixed, okay. Pivoted at a point when a force is applied on it, the body starts to rotate about its axis of rotation. Remember the compass pointing you, that's the axis of rotation. Yeah. Now we'll keep the first case there and we will study the rotational motion case in detail. Are you getting bored? I'm very sorry if you are getting bored. I am sorry for you. How can you get bored? Okay. So, I'm going to fix this body. This is the pivot. Okay. Now I'll mark it for you. Yes. Oh, yeah, that's fine. Oh, this is the... I'm getting excited. That's why the things are shivering. Okay. Now this is the pivot. Now see, this body is fixed here and I am going to apply force in this direction. So the direction in which I apply the force, see, I am applying the force, okay. So invisibly this force is going like this. Can you see this line? Can you imagine this line? Right. So this line where the force is being applied is known as the line of action of force. Yeah, that's line of action of force along which the force is acting. That's a line of action of force. Now see, do you know what do you mean by what does perpendicular mean? Yeah. Okay, so perpendicular just means 90-degree angle, okay. When one line is perpendicular to another line, we say that the angle between those two lines is 90-degree. What happened to my English? Okay. Now I am going to take the perpendicular distance between these 2 points. See? So where did I take the perpendicular distance? Between the line of action of force and the axis of rotation. Right? Axis of rotation and line of action of force. I will name this as D. And this is the force. So the turning effect. Now we really need to measure things, right? To convey it mathematically. In case of linear motion, it's simple, you have the laws and all. But when it comes to motion like a rotational motion, when I apply a force, okay, this is the line of action of force, and I take the perpendicular distance and I name it D, I'm going to introduce a new term, stylish term, torque. Torque. Yeah, torch, no, torque. Remember it that way. It's also known as moment of force, or you can call it torque. So the measure is simple, torque or moment of force. I am writing it like this. Don't write like this, you will lose your marks. Okay. The moment of force or torque is equal to, can you guess it? Right, force into perpendicular distance. That's it. Oh wait, is it flipped? Okay, moving forward. Sorry for the inconvenience, I noted it, but that's okay, right? So, moment of force is equal to force into displacement. That's the only thing which was flipped. All other things you can understand. Thanks for understanding. Okay. So, when I have to define it, I define it this way. The moment of force acted upon a body is the product of force along. Force in what direction? I said that gravity is also pulling you. So there are many n number of forces acted upon a body, which is acting upon a body. Okay. So the perpendicular distance and the line of action. So I drew it so clearly for you to understand that the force is being acted along the line of action of force, and product of line of action of force and the perpendicular distance between the axis of rotation and the force. That's, I'll tell it again, okay? I know it's a bit confusing. The moment of force is the product between what? F into D. What is F? Force. Force acted along what? Along the line of action of force into D. What is D? The perpendicular distance between the axis of rotation and the line of action of force. I know it seems big, but it can be compressed to F into D. When you have to write it in words, just expand that F as F along line of action of force, and that D as perpendicular distance between what? Axis of rotation and line of action of force. So that's it for today. We learned about force. We took two cases, rigid body and non-rigid body case. We took the rigid body case and studied it in detail. We spoke about the two kinds of motion, linear motion, rectilinear motion, which is also called as translational motion. And case number 2 was rotational motion. In case of rotational motion, we learn to measure rotational motion. We learn to measure the moment of force, which is also known as torque. So the expression is simple: moment of force is equal to F into D. That's it for today, guys. I hope you enjoyed this session. We'll be coming back with another topic next day. Not next day, will come soon. Okay, till then, keep learning, see things, observe them, think and explore. This is Tarishri NS signing off. Goodbye.